Welcome back to the Java OCP 21 series. I am Arup from ClusterMicro Technologies. So this video covers inner classes, one of the biggest topics of OCP exam and one that confuses candidates more than almost any other object. Okay, so the confusion is very understandable. Java has 4 completely different kinds of inner classes, each with its own syntax, its own access rules and its own instantiation pattern. Okay, so mix them up on the exam and you will get the question very wrong even if you understand the concept. So let me name all the 4 up front here so that you know what is there. Okay, so we have member inner class defined inside a class body outside of any method, right? So has full access to outer classes including private members, so and it requires an outer class instance to be created. Then we have static nested class defined inside a class body with the static keyword. It does not require an outer class instance. Okay, so it cannot access instance members of the outer class directly. And then we have local class, which is defined inside a method body, only visible within that method only. Okay, so and it can access effectively final local variables from the enclosing method. Okay, and then we have anonymous class, a nameless class created and instantiated in one expression. It is used for one-off implementations of interfaces and abstract classes. So we are covering the member inner class now. So let us see what is there in the code. So here we see class outer private int x is equal to 10, right? So outer is a regular top level class with one private instance x set to 10. Inner is declared directly inside outer class's body, outside any method or constructor. So this makes it a member inner class. It is a member of outer just like a field or method is a member. Okay, so the defining characteristics of a member inner class is that it has an implicit reference to the enclosing outer class instance. Every inner object is permanently associated with the specific outer object that was used to create it. This implicit reference is what enables the access to outer class members. Okay, then we have system.out.println x, so it is accessing outer's private field. Okay, we have to understand this. Inside inner.show we reference x directly, and x is a private field of outer and yet inner can access it without any problem. Okay, so this is a fundamental access rule for member inner classes. A member inner class has access to all members of the enclosing outer class, including private fields, private methods and private constructors. The access modifier private applies to external classes. Inner is not external to outer. Okay, it is inside it. The inner class is part of the same compilation unit and has unrestricted access. Okay, the x in show refers to outer.this.x. Okay, the x field of the specific outer instance that the inner object is associated with. So if you need to be very explicit, for example, when inner also has its own field name x, you write outer.this.x to clarify. Okay, also you have another way to do this. So if you see the code here, we have system.out.println outer.this.x. Okay, so the exam tests this syntax of outer.this. Okay, so it is the way to explicitly reference the enclosing outer instance from within the inner class. Okay, then let's check out this code. Outer equal to new outer, then outer.inner inner, outer.new inner, then inner.show. Okay, so here we have outer equal to new outer. Okay, so a standard outer object is created here. So this is required. You cannot create an inner without first having an outer instance. So outer.inner, then inner equal to outer.new inner. Okay, this is the second line. This is the instantiation syntax for member inner classes and it is unlike anything else in Java. Okay, the exam tests this syntax very specifically. Outer.new inner, here what is happening is that the new keyword comes after the outer instance reference, not at the beginning of the expression. You are saying using this specific outer instance, create a new inner object associated with it. And the type on the left is outer.inner, the qualified name. The outer class name dot inner class name. Okay, this is how you refer to the type from outside the outer class. Okay, so why is this syntax different from normal? Because every inner object needs to be tied to a specific outer instance. The outer.new inner syntax makes this very explicit. You are creating an inner that belongs to the outer. Okay, So a plain new inner would have no way to know which outer instance to associate with, okay? They simply would not know. So here we have inner.show prints 10, right? So this method runs, it accesses outer.this.x, the x field of the outer instance this inner object is associated with, okay, which is 10, and it will print 10. From inside the outer class, if you create an inner from within an outer method, the syntax is very simple. So we have to say here, like in the code, class outer void create inner equal to new inner, okay? So inside outer, this is already available. The compiler implicitly uses this.new inner. The outer reference is assumed to be the current outer instance, okay? Say you have another inner class, how will you access, right? From another inner class instance. Say you have two different outer instances, inner 1 and inner 2. So they will have access to different x values, their own associated outer instances x. Inner objects are truly tied to their specific outer instance. Now we have something called static member restriction, okay? Before Java 16, member inner classes could not have static members, okay? So writing static int s is equal to 0 inside a member inner class was a compile error, okay? The reasoning was that a member inner class requires an outer instance to exist. It is inherently tied to an instance context, okay? So static members belong to the class itself, no instance is required. This is a conceptual conflict that led to the restriction. We have to understand this very clearly, okay? A member inner class requires an outer instance to exist. It is inherently tied to an instance context, okay? But static members belong to the class itself, no instance is required. So how it will happen? So this is a conceptual conflict that this led to this restriction, okay? So there was one exception, static final constants were allowed earlier, okay? Static final int constant equal to 42. Constants with compile time constant values are permitted because the compiler inlines them, okay? They do not actually require class level storage. But Java 16 onwards, Java 16 relaxed this restriction as part of a series of refinements. Member inner classes can now have static members. The compiler error is gone now. The OCP 21 also, exam also, this tests this change, okay? So you have to know both the pre-Java 16 rule and the Java 16 relaxation. If an exam question shows a static field in the member inner class and asks, does it compile? The answer depends on which Java version context the question implies, okay? For OCP 21, Java 21, it compiles. So when will you use a member inner class? Member inner classes are used when the inner class is logically part of the outer class, okay? And it needs direct access to the outer class's instance state. So we have many examples here, it's widely used. So say iterator implementation, a collection class like a custom linked list implements its iterator through a member inner class that has direct access to the list internal nodes. Then we have event listeners in older swing AWT code, okay? So button click handlers as inner classes that access the surrounding form state, okay? Then we have builder pattern variations where the builder needs access to the outer class's private constructor. So the defining signal is that if the inner class needs to access private instance field or methods of the outer class, it makes conceptual sense for it to be part of the outer class's definition. So a member inner class is the right tool, okay? Thanks for your time. If you like this video, please like, share and comment. That helps this channel a lot, okay? Also, if Java certification is on a roadmap, our platform for OCP is also out now apart from OCA. The OCP platform is available on ouc.clustermicro.com. It is a platform built specifically for Java 17 and Java 21, okay? So we have 1884 practice questions for Java 17, then 2074 Java for Java 21. These are very well reviewed, and then we have 78 full-length time mock exams totally, and you can pick 17 or 21, whatever you like, okay? So thanks for your time. Let's meet you in the next video. Again, please don't forget to like or share.